days, it's gotten worse. So I'm hoping that my brain stays functional. One of the things that I wanted to help everybody with, and I haven't been able to get around to every single person, but going through these problems here, we're just trying to develop these rules. So I wanted to take you through the last one here. So if we kind of look at what they're saying like, oh, well, we have x cubed. So if we were to, let me go ahead and blow this up. If we were to rewrite that, then we can go ahead and rewrite it as the same as this thing. And we know that it must work like this. And so if you don't see the step from here to here, then let me ask you this. And it's just kind of a lead question. If I wanted to add 2 10 times, so I go 2 plus 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 2, and you can't see, but I'm counting on my fingers. Would you truly do that? Or do you know that, well, if I add 2 to itself and I have 10 of those 2's, then 2 plus 2 plus 2, and there's 10 2's, is really just the same as 2 times 10. That's really that's exactly how they're making this jump. They're saying that, okay, well, I can rewrite stuff inside as being to a power as that times that times that. But according to my first rule, I can rewrite things multiplying inside as adding on the outside. And then I'm suggesting that the leap from not only from log base 2 of x plus log base 2 of x plus log base 2 of x to 3 log base 2 of x, but also to this one down here, is to think of it like this. So if you have x, or if you have k x's, and you're multiplying them, then what you're going to have is you're going to have log base 2 of k plus log base 2 of k plus, and you're going to have, oh, I screwed that up. See, this is why my brain is like semi non-functional. It's not k, ding dong. That's x. And then log base 2 of x, and you have, this is where the k comes in, you have k of those. So in that case then, I can rewrite it as 2 times, and so it's the thing that I'm multiplying, this, or thing that I'm adding, this log base 2 of x. So just like up here, and it works exactly that way. Log base 2 of x, I can write k times. And that's it. That's all it's looking for. So you can make the jump that if you have log base 2 of x to the k, you can go through this this particular thought process and come back to k times log base 2 of x. And it really kind of makes sense if you think about it just from an exponent rule. So if we take a look at the exponent rules, it says that if you take a to the m, and I'm going to use k, I'm going to say to the k, then all you do is you multiply m and k. So raising a power to a power is the same as multiplying them. But we also talked about logarithms being exponents. The answer to a logarithm is an exponent. So if you raise an exponent to an exponent, you multiply those exponents. And it just kind of comes out like that. Now, if you want a formal proof, there's a little more to it, but that's the idea. It's trying to get you guys to think in different ways. And that's all it wants. So to finalize this process, they go through, and in number 12, they summarize these rules for you. So right now, you've only looked with base 2. But the question is, so long as the base is larger than 1, can you think of any reason that it shouldn't work for any base? And that's the key. That's what they're looking for here. All right. so now our takeaways. Excuse me, I apologize. Properties of logarithms. All that we want to know. These are our takeaways. If I see log base b, does not matter what the base of the log is, then I can, if it's multiplying inside, I can add the logarithms. On the surface, this doesn't mean a whole lot, but without a calculator, oh my lord, trying to find these logs and calculate them, you want to use any trick you can because it's a hot mess otherwise. Notice, however, and this is the key, notice the bases are all the same. So a for instance is, this does not work. Log base 2 of x plus log base 3 of y equals log base 6 of xy. That is not true. The bases have to match. So keep that in mind. The other two are simply if you multiply and it leads to addition, then if you divide it leads to subtraction. Watch the order. It's always the top minus the bottom. And then finally, if you raise a power to a power, so in a logarithmic form it looks like x to the k. If you have an exponent inside, notice that the x value and the b value do not have to be the same. These are not inverses of each other. Not necessarily. But if you have this structure where you have a base and an input, and then you have a power on that input, then you can bring that power out as a multiplier. And that's it. And if you wanted to check it, if you put in b for x, you'll find out that it works out just fine. Because log base b of b is just 1, which would take this whole right side to k. And we know from this side, if x were to be b and you have log base b of b, those are inverse functions. And so you just go back to the input, which is k. And that's it. That's all they wanted you to see. That's all. So now, we have to be very careful here because we're trying to keep this in practice, trying to keep this in our wheelhouse. Write the expression using exponents. Okay, so remember, it's the power over the root. And you can distribute powers. So this is going to be 54x to the 6th raised to the 1/3 power. But that means that you can send this to and distribute that 1/3. So this becomes this 6 times 1/3, which is just 54 raised to the 1/3. And then this becomes x squared. Now, you raise it, if you rewrite it as the first thing here, I'm perfectly happy. We're good with that. If you want to carry it through and you see that you get an x squared, I'm perfectly fine with that too. So rewrite log base 2 of 1/3, or I'm sorry, of cube root of 8 is the fractional exponent. So again, we want to take log base 2 of 8, but because it's the cube root, it's the power, which is the power on 8, which is 1, over the root, which is 3. Now we could figure this out. We could just say, well, wait a minute. Well, that's just 1/3 times the log base 2 of 8. But we know what that is because we know this piece from earlier. That's just 3. So 1/3 times 3 is just 1. This whole mess is just 1. That's it. Rewrite this equation, and now it's not a matter of whether or not it's true. Happens to be, but it doesn't have to be true. Just look at the format and remember that when we had a to the x equals y, we can rewrite that as log base a of y equals x. The answer to a logarithm is the exponent. The answer to the logarithm is the exponent. That's the whole idea. So if we just match this up, 6 is the base. So it becomes log base 6. 5 is the answer because 5 is the exponent, and then we just put 7776. 7776. And you're done. All right, so really quick, and I'll make a little jump to it so you guys can just jump to it if you need to. But I'm going to go ahead and I'm going to open up the Ready, Set, Go. And I'm going to just do one of each for y'all. assuming I can find out where it's saved. Yeah, assuming I can find out where it's saved. Give me 1 second here. It should have saved in here, but it didn't. It's very, very angry. So let me go back. Where you at? You are in documents. Oh my. All right. Well, this is well hidden. Let me go find this here. Documents, wraps, unit 1. I don't know why it's in here. All right. So rewrite the following expressions with an exponent instead of a radical. Quite literally, it's not looking for you to do much. You don't have to go to the nearly to the extent, but you're just saying, okay, well that means it's 125 m to the 5th. All of that stuff. Remember, it's the power. All of that stuff is raised to the 1st over the root. That's it. That's all it's looking for. You don't have to go any further than that. It's just hammering down, because we are going to go back to these and we're going to learn how to reduce these. But you have to be able to go to this route first. So we're going to hammer down on that later. Rewrite the fractional exponent, then evaluate. So if we take a look at log base 7, so let's do 11 here. So we've got log base 7 of 343, and we rewrite this to the 1/5 power. Well, using our third rule here, we can take that 1/5 out as a multiplier. Then we have log base 7 of 343. Now, I don't know what that is, so I'm going to rewrite it like this. It's going to be some value, but I'm only concentrating on this part. I don't care about the 1/5 yet. So 7 to the x is equal to 343. So I need to find out what power it is. So, and again, you can't see it because I'm just awful, so I don't have my camera on. But I'm holding up my fingers, and I'm saying 7 to the 1st is 7. 7 squared is 49. And if I take 49 and I multiply it by 7 in a calculator, I actually get 343. And that took 3 sevens, so x is 3. In that case, then, we know that we can replace this log base 7 of 343 with the number 3. So now we take our 1/5 out front, multiply it by 3, because that's what log base 7 of 343 is, and therefore we go ahead and give it the value of 3/5, and we are done. The end. Alright, now the set. Use the graph to write an equivalent function. So now this is the stuff that we actually did inside the lesson. They want you to show that this is a shift downward. So if we look at our basic values, we've got the value 1, 0 here. Every parental log goes through that point. So if we move down and we see it, it's like, oh, well, it moved down 3 spots. So this has to be log base 3. Remember the 3. Log base 3 of x minus 3. And that's it. That's all they want you to do. The end. You're done. Okay, so let's take a look at the rest. So select all the functions that are equivalent. For each function you select, show y is equivalent to h of x. All right, so here we go. So now I'm going to choose A, and then I'm going to tell you why. 40 is actually equal to 5 times 8. And then if I rewrite log base 10 of 40x, I can rewrite it as log base 10 of 5 times 8 times x. Remember from the third, when we were looking at the third rule back in the lesson, we said, all right, well, that means that I can just add those logarithms. So this becomes, because of my first rule, I can split it as log base 10. If you just want to use log, because it's a base 10 already, that's perfectly fine. So this is just log of 5 plus log of 8 plus log of x. And it's addition, so it can happen in any order. So there's this one here. There's this one here. And then for purple or violet or whatever, there's that one there. So A is good. It is equivalent. And that's what they're looking for. Each one. Go through each one and show that it must be equivalent. Be careful on C, please. Be careful what it makes you do. Same idea for 16. You're going to go through and show equivalencies. And then on the go, convert to a logarithm. This is all stuff that we have dealt with. And so it's just wanting you to go back and forth between the two forms. That's all it's asking you to do. So if we take, for instance, number 18, you can write it a couple of different ways. It's going to be log base 10. And then the answer is the exponent. And then whatever's left goes in here. You can write it like that. Or because it's log base 10, the common logarithm, you don't need to be explicit with the base. It's assumed to be 10 if there's no base there, and it's log instead of ln. So we can rewrite it like this as well. And that's it. Now, convert back. Again, we're just converting back, and so we have to be able to go back and forth. So taking number 22 here, you'll notice it's a fractional base. Now, realistically, you and I don't deal with that very much. But it still holds true that this follows the order. So remember that log base b of x is equal to y can be rewritten as b to the y equals x. So we just look at the structure and we input those numbers at their appropriate spot. 2/5 is the base, it stays the base. The answer to the logarithm is the exponent, so this gets cubed. And that equals whatever the input was. Notice that the x out here, the x is now inside the logarithm. And so you match the locations. And that's it. That's all you're doing. All right, work on these together. There's a little Delta Math assignment, so keep that in mind. And then if you have any questions, feel free to ask the sub. If they can help you, great. If not, hold them. Give me questions for tomorrow. All right? We are going to finish this up and move on to lesson 4 tomorrow. All right, we'll see everybody tomorrow.